Hey guys, welcome back to another RESK coding video, and in this video I'm going to be continuing on the neural network learns arithmetic series. So if I bring out the plan which I made out last time, you'll see that we have pretty much a few basic steps which you need to get past. So first of all, we have to figure out the data, and the good thing about arithmetic is that it's really easy to just create data. We can just create data and we don't have to go and find it. So we're going to be doing this step, and we're also going to be doing this step in the video. So once I've created the data, I'm going to be training the first neural network to identify what the operator is. So I'll show you guys a bit more about that. Let's create what we want our data to look like. So the idea is we want our neural network to detect what the operator of the equation is. So what I mean by that is if we have an equation 1 plus 9, let's just say that. So in this case the operator is the plus sign. If we had the equation 81 times by 81, then the operator is multiply or times. So we just want to create we just want to have a neural network take in a question like this as input and return out the output like this. So I'll just put in the other two examples so it's clear what we're doing. So if you have 100 minus 5 or 4, that's going to give us minus. And finally, if you have like 64 divided by 9, then we will have a divide or slash in our case. So yeah, we want to input data like this and output the corresponding operator. So to do this, there's multiple ways, and I've actually been thinking about it a lot, but what we need to consider is we basically need to condense, or not condense, but we need to represent this question in a standardized form. So condition 1 is it needs to be a fixed size. So question must be fixed size, and the reason for that is because our neural network is going to have a fixed number of input layers, input neurons, so we can't be putting in different lengths of questions because that's not going to work, because our neural network only has a fixed number of input neurons. So each question needs to be the exact same length. And the second constraint is we need to represent this question in a sort of binary format, if that makes sense, because although you can just put in numbers, we could just divide it by you could just normalize it to 1 and then put it in. That's going to require a lot of precision, and it's going to be much more easy to train, I believe, if we convert everything to binary. So here's the idea. We're going to take the question as a string and we're going to convert it to binary, so ones and zeros. So that way we're still encoding all the information, but we can put each input neuron can have either a 1 or 0, so we're maximizing the amount of not sure how you say it, but sort of area that we're covering. We're going to be maximizing the training entropy, I think. So yeah, that's the plan, and of course the output, or expected output, is just going to be an array. So the final output layer is just going to be 4 neurons, and each one represents a operator. So if this is 1, that would represent subtraction, because it's going to represent like this. So yeah, we can actually have a look at how the neural network wants its inputs and outputs. If we go over to network.cs, and you can see we've got a data point, and also let's go over to the neural network over here. So yeah, we can just see it's pretty easy to train once we've actually got it. So all it wants is some data, and we just have to put in the inputs and expected outputs, and if we just pass this data in with a few parameters, give it to train, and it should train, and we should be able to see the cost function going down. So yeah, let's get started. So first thing I'm going to do is I might speed up this process because it's the main idea that counts, and I can come back and explain it later. But yeah, so let's get started. Going to create the main function. Okay, so let's create this actually in Node. That would probably be a good idea. So okay, so I've started on the data generation. I've actually done it in a new node.js file because that will allow me to write it and then we can just use that as a JSON. But yeah, so I've written it to I've started a new node.js file and I'm basically looping through two numbers going from 0 to 999, and we're going to be generating all possible questions for each number. So this should be pretty interesting. Now we need to make sure you can get the fixed size, as I said over here. So what we can look at is the max size. If it was a 3-digit number, any operation, and then times another 3-digit number. So the max size of that, max size of any input we could possibly get is going to be 7 digits. So now what we can do is, if our number is less than 7 digits, then we can simply add more zeros to the front like this, because that's not going to change the value of the operation. Just might look a bit weird, but yeah, so we're just going to change it until it reaches that 7-digit threshold so that we can get all of our inputs the same size. Okay, so we've now converted our text to binary. I've just looked on Stack Overflow and found a function which is going to convert a string into a binary. So I can just show you guys what this is going to look like. If we console.log the question and binary, then you should see that all these questions are being normalized. So you can see it's randomly generating the operator, which is the thing we want to test. And we're also randomly normalizing this, and we're making sure the operator is in a different position each time, you can see. So that's also good. And let's just see. Okay, yeah, so that's pretty good so far. One thing I'm noticing is that we may have to also randomly decide between putting the zeros at the front or after the operator, because otherwise it's all going to be at the front, so this is only going to shift here and back, and we're never going to see the shift to the left side, and that might be a problem when we're training it. But anyways, this is the main idea. So we can see we're converting all this question into binary, and we can just feed this binary into the input layer of the neural network as just ones and zeros. So that's pretty good. Okay, yeah, this is good. So I've implemented a different sort of system. So instead of just adding it to the start, we're actually going to be randomly selecting between adding it to num1 and num2 until their combined length is 6, because we have to account for the operator as well. But yeah, so now you can see we're getting a lot more variation in our numbers, and yeah, this is good, because generally in neural networks the more variation you can get, the better, as long as you have enough training data, and I think we do have enough training data, so this is good, this is good. Okay, so now I've successfully converted the binary question and answer into into a list of inputs and outputs. So you can see, for example, this one is going to be the input and this is the output, and this is great because now we can just feed this data into a neural network and let it learn. So for example, I'll show you guys one example. So let's take this and let's simply change this quickly so we can actually see what this is doing. So I just replace the comma and space with nothing, and also okay, that should be fine. Now let's go to a binary to text converter. I think this should be good. And yeah, one thing you might actually have to do is you might have to fix this binary a little bit. Okay, so I believe it's split into chunks of 6, so we actually have to fix this quickly. Okay, and then we just gotta add some 0 padding, like so. Okay, so now you should see this should be a subtraction sum. So let's see if it is. Okay, and it is. That's good. So you can see we've got 11 minus 20. It's got some variation in how the subtraction is placed, and yeah, that's pretty good. And you can see I could tell that was subtraction because of the answer output out here, 0, 1, 0, 0, and this represents addition, subtraction, multiplication, division. So the important thing is that this binary data is actually encoding all of the data within this. So it doesn't matter how it's encoded, it just matters that all of the data which you want is encoded in some way within this. So we could retrieve it if we wanted to. That's what that means. So now I've reduced our questions down to inputs and outputs. I'm just going to add them to a data value and data list, and we will shuffle them around and then split them 75-25% into training data and testing data, just so we can make sure the network isn't memorizing the answers. So let's start doing that now. Okay, so I think I'll actually end the video around here now, because this took a lot longer than expected, but I'll just do the training of this data in the next video. So this is what we've done so far. We've actually generated an entire list of all testing data and training data, which is just going to appear here. This file's really laggy because this is very long, but I'm just going to close that. So you can see here we have 750 what do you call them, like samples, 750 samples of training data and 750,000 samples and 250,000 samples of testing data. So that should be plenty to do training and testing. I might even make it a bit more split towards training, because testing we really don't need that much. But yeah, it's good to have it nonetheless. And I've actually shuffled the data already, so we should be getting a random order. And yeah, so now all I've done is we can use these text files, load them into JavaScript, and then we should be able to start training our network. So just to give you an idea of the training data, it's really slow. Let's just go back to the start. Okay, so it's going to pass in an input, and I believe this is a list of 42. This is a list of 42 neuron values. Let's just make sure of that. Let's do something like, oh, okay, yeah, I won't be doing that. But yeah, so we've got a list of 42 neuron values, and then we've got the expected outputs. So in this case, our expected output would be multiplication. So yeah, we're just going to be getting the network to detect if we're going to be getting a network to pass in calculations like this, and it's just going to detect the operator, because once we've detected the operator, we can simply split the thing at that the list equation at that operator. Then it knows what operator is, and from there we may be able to pass this data in as extra weightage, or we might even be able to split up, set up more neural networks to handle each different operation. So we'll decide on that later. But yeah, in this video we created the training data to use using this Node.js file. We simply just loop through 1,000 iterations of each, creating this, and turn it into binary, because we need to we need to use that data to its max potential and not just normalize it, which would possibly lose data. So we've converted it all into binary, split it into training and testing data, written it to a file using Node, and yeah, now we can load this in, and next video I'll be training the networks. So stay tuned for that. Thanks for watching, and I'll see you guys in a future video. Bye.